Hello there, this is Daniele from Toolchefs and welcome to this new video. For this tutorial I'm using Atoms Maya 5.0.1 and Atoms Unreal 3 beta version 11. If you're going to follow this tutorial, just make sure that at least you have these versions or above. They contain some important updates that will let you follow this tutorial without any problem. So today we're going to have a look at how we can use quadrupeds inside our Atom simulations. We're going to use also an hybrid workflow, so we're going to prepare all our assets, so the agent type, the animation clips, and a state machine in Maya, and then we're going to export this setup as a JSON file, and then import it into Unreal Engine. Also in Unreal Engine, we're going to have a look at how these assets look. So if you want to do everything in Unreal Engine, you can also do that. You can, of course, use the same workflow if you use Houdini, so you can prepare your setup there and then export it and share it with Maya on Unreal Engine if you want. Okay, so the first thing that we need to do here is we need to export the files that are necessary for defining the agent type. So to do that, I'm going to open the rig animation exporter, and we need to select the root of our skeleton and click on the pick from selection button here. Here you see that was already selected, but every time you work with a new skeleton, you have to pick the root before you can proceed with setting up the rest of the UI. So if you already looked at other videos where we set up bipeds, you already know that basically here we always add the pelvis, and but for bipeds we just have one because we have just two legs. In case of quadrupeds, we actually have two pelvises because maybe you can consider them like as the roots of the legs. Okay, so because for quadrupeds we have four legs, we need two pelvises. So the first joint I'm gonna add is the root here because that is actually the let's say the pelvis for these legs here, and then also this joint here, which is I think is the chest. Yeah, it's the chest joint. Then we can add the foot root joints. So before we do that, one thing in Atoms, if you have when you're setting up feet for your skeletons. Basically, you do that because you want the foot locking working during the simulation. Also, you have to be very aware of that of the fact that for chains of more than 3 joints, we don't use like the fast IK algorithm that we use with standard bipeds. But we actually have we started using Fabric IK, which is like another algorithm which is more expensive computationally. So what we prefer to do is define the legs with just 3 joints, and like for instance for this leg here, we would say that the root joint of the leg is this one, and then we use this one for the other. Sorry, not the foot IK. Sorry, for the foot roots, like that. And then what we do is like we select the third joint. So 1, 2, 3, this joint here will be our foot AK. So where the AK chain ends. And in this case, because we selected these joints here would be these joints. Okay. And finally, we can select the foot tip, which are actually the joints that touch the ground. So these are 2. And then I think it's these ones. I wanted to press here. Yeah, it's this one and that one. Okay. Cool. Okay. So we're all set. Now we can pick the skin geometry. So we select the group containing the skin geometry. We can select an output path. And one last thing before we export, we can select the locators that are used for the pole vector, and then we can just move them a bit forward. So the other one is there. Did we move it? And actually, sorry, this one I think. Yeah, okay, these ones probably it's best if we move them here, and then these ones. Okay, they're there, so they are fine. Okay. So once that's there, that's done, you can just click export. So the files have been exported, and now let's go and work on the animation clips. Okay, now we can export animation clips. If you have FBXs, you can use them directly inside the Atoms UI and then do most of the work that you would do with animation exporter. directly inside the Atoms UI. In this video, we're going just to go the full circle, so I'm going to even show you the animation exporter. So we're going to open it, so it's going to be export, click animation exporter. We have this animation tab, then you select your root and click on pick from selection. You provide a file path. I'm going to call it, in this case, walk. I'm going to drag and drop it here, the walk for the Labrador. So this is the original FBX that I prepared for my Labrador here. If I press play, the Labrador is working, it's fine. Then we can, the only thing else that you have to do is like to provide a ground height. So in this case, I know that the clip the animation was done above the XZ plane, so the ground height would be 0. If you select one of the foot tips when the foot is down and click on pick from selection, you see here the value is around 0.6. You can usually, because I know that the animation was done above the XZ plane, I'm gonna provide the ground height set at 0, but I'm gonna provide a foot threshold, and in this case maybe I'm gonna provide 0.9 or something like that, because I know that this animation basically the other joints, the other foot tips, they don't have they have a higher ground height values. So just even if you use this button and you want to use the ground height set to 0, just remember to set it to 0. Don't worry too much about what you provide here, because you can fix this stuff later in the Atoms UI, which is also what we're gonna do. So once you have prepared everything, you can click export. So that's done. Now we can process the run. And once again, I'm not gonna care too much about providing, changing these values here, because we're gonna fix them later in the Atoms UI. So I'm just gonna change here the name of the file. So we're gonna call it run this export, and then also the other animation, which is the walk to run. Like this. You might be wondering why you should use the animation exporter if you can do everything in the Atoms UI. The short answer is that animation exporter bakes automatically at export time some data on the skeleton, which anyway can be added later from the Atoms UI. But again, if you want to have less work to do in the Atoms UI, you can use animation exporter, which will set up the pelvis height and feet height, and also the foot down states for you. Also, another thing that I forgot to mention before exporting the animation clips is that you always want to export your animation clips from the scene that you use for exporting the agent type files. And this is because you need the joints, like the feet joints and the pelvis joints, to be tagged so that the right information is baked on the right joints. So now let's go in the Atoms UI and start preparing our assets. Okay, so now we're in a new scene. We're going to open the Atoms UI, and now, first of all, I'm going to clean the content that we already have in the Atoms UI, because this is like the setup that we have for the Atoms JSON, the default Atoms JSON, which we don't care for now. The state machine. Okay, so first of all, let's work with the agent type. I'm going to call it dog. We're gonna pick the skeleton file. So this is the file that we just exported, and then also the skin geometry, and also we're going to change the scale multiplier to 2.5 because this skeleton is quite small, so we just want it a bit larger. I'm going to click register. Here we see that with the current highlighting, everything was set up properly. So we have the green joints are the pelvises, the light blue joints are the foot roots. Pink ones are the foot AKs, and then the yellow ones are the foot tips. Okay, so this is done. Now we can go and start looking to the animation clips. Now for the animation clips, let's create the first one. Let's call it walk. We're gonna point it to the walk FBX we just exported. So this one. Here there are some properties that we have to set. The first thing anyway that you notice that as soon as you set FBX, here we see a preview of the Labrador skeleton being animated. If you use other file formats like Atoms clips, you might have to set the compatible agent type here, which is always a good practice, so I'm going to do it anyway before you can see the preview. Then the first thing that you want to do is you want to set the loop start and loop end of your clip. So of course you need to set 2 frames for a single clip, so the start and end frames, and where basically these 2 frames they match. So for instance, frame 22 and I think next one is frame 44, something like that. Let's see, 22. Yeah, they match. So I'm gonna use 22 and 44. You have to anyway. You need to prepare your clips so that they are loopable, but also if you want to go from a clip to another, so for instance from a walk to a run or a walk to run, you have to make sure that the end pose, also the loop end, is actually matches a similar pose or the same pose for the next clip. So for instance, for a transition clip, you would have to match the same pose. If you were to blend from walk to run, you would have to make sure that the foot down and the pose is similar. So for instance, this foot have to be down, this foot has to be down, and so on. Okay, then we need to provide the direction type. So I'm gonna set joints. Usually for bipeds we use a static direction, but for quadrupeds you can use basically 2 joints to provide the direction of the animation. Here we can say, for instance, the direction, so basically the direction in this case becomes the vector that goes from the joint with this ID to the joint which has this ID. Usually what you do is like you provide the 2 pelvises that we have set up previously. So it was like the root M, that one, and also the chest M. So we need to find the 2 IDs, which anyway they are here, so 26 and 0. So the second one will be 26 here. If you also want, you can also use the agent type joints dialog. So you could type chest, and that's your ID. So you can type it there. Then you remember before we used animation exporter, so that now the pelvis and feet height data is already stored on the skeleton joints. If you basically have your FBX that is coming from Motion Builder, so you didn't go actually through our animation exporter, you can select this option here and provide the ground height, which in our case would be 0. I'm not going to do it because again that data is already stored within the skeleton. Then for the foot down data, you can either compute it directly in the Atoms UI here, or you can load it from clip if you have already the foot down data stored there. So in this case I'm gonna load it, and what you want to do is you want to make sure that the foot down is properly configured in your frame range. So we only care about these 22 frames, okay, between 22 and 44. So we see already that this joint here should be down and it's not. So that joint is toes and L. So it's one of the foot tips. So you see here, actually let me remove the joint names. There is down, but there's no, the disc is not appearing, so the disc means that the foot down state is on, which is not in this case. So let's look for that joint. So it's here, so we say from frame 22, take those frames and we break them up. Okay, and then also I think towards the end of the animation, here at 44, here it should be down already. So maybe from frame 42. Okay, now I saved it. Let's see, 22. Let's go frame by frame. Okay, looks okay. So I'm gonna save this one, which I already did. And now I'm gonna configure the other 2 clips, but I'm gonna do it, I'm gonna fast forward the video so you don't have to wait for me to set them up, okay? Okay, so now the clips have been set up. As you saw, just for this, the walk to run, I've disabled the loop. option here because of course this clip is not loopable, it's just a transition clip. And now let's have a look at the state machine. Now we can prepare the state machine. So let me create a new one. Let me create a couple of states. So this is gonna be the walk, here, and then the other one is gonna be the run. And also here we're gonna add the run clip. Gonna create a connection between them. And I'm going to add the walk to run clip here as a transition clip. Okay, so I'm not gonna do anything else there. Maybe we're gonna get later back to that and fix it if in case we need it. And just to test it quickly, can create a grid layout with the dog, and then a state machine. So 0 is fine. Let me change the display type to skin. Cool. Okay, so maybe here we can say I want the state to change from 0 to 1, just to change the. Actually, first let's see if the animations work okay. Okay, so this is the walk, it looks right. This is the run. Which also looks okay. So now we can try the transition. So we can go here. Let's see. So we're gonna set a couple of keyframes. Okay, looks good. That's great. So now we are ready to export these and take it into Unreal. So we're gonna go under Atom Scene, Export Scene JSON, and then we're gonna select our destination folder and call it Scene JSON. And this dialog says that it was exported successfully. So now we can go in Unreal. Okay, so now we are in Unreal. First thing, I'm going to create a folder. Call it Atoms. Then I'm going to drag and drop the JSON that we exported earlier inside this folder. As you can see here, Atoms is creating all the Unreal assets. I'm gonna save them straight away. And as you can see here, we have a skeleton. This skeleton has this asset user data, which is an Atom's user data that basically contains the information that we exported earlier with the rig exporter. So we have, you see, two pelvises, and they are basically here we have the names for the two pelvises that we tagged earlier, and also the information about the legs. So we have each leg with the foot root, foot decay, foot tip, and the pole vector. So in case you decide to use your own skeleton directly in Unreal, what you have to do is you have to create this skeleton user data and provide the pelvis and legs information here. Cool. So after that, also here we have the skin mesh, which is just a regular skeletal mesh with the material and 4 LODs, which are being generated automatically when we import the assets from the scene JSON. Here also Atoms creates this a variation asset, which is used by the agent type definition. The variation asset is basically just a collection of skeletal meshes. And here in the agent type, you see we have a reference to that asset, to the skeleton, and to the state machine. So the state machine is the state machine that we defined earlier in Maya. So it contains the two states and the transition with the walk to run clip. One thing about the clips before we go to the simulation stuff. So if we open the walk, for instance, even in here you'll find this asset user data. We have an unclip user data that again contains all the information that we defined within the Atoms UI. So the loop start, loop end, the direction type, so the joints, so 0 and 26. Here we have the compatible agent type and so on. The information about the foot down is actually stored in here. So here we have a bunch of information for the pelvis velocity, but down here also we should have, let's see, the foot on ground state. You see here we have these curves here saying basically when the feet are down or not. So basically, if you do this stuff directly in Unreal, you might have to create these animation curves yourself. For the actually you can compute it, sorry, but then also edit it if you want. But also you can compute the transition frames if you want. And if for the pelvis height, you can even in here, like you could do in the Atoms UI, provide override ground height, and you can enable this option and provide the ground height here. Okay, so that's all done. Now we can start with the simulation. So in here, let me delete this and create a landscape. Just quickly, we're going to just modify it a little. Okay. So, okay, I'm gonna go in select mode. I'm gonna create an atoms group. I'm gonna put it there, grid layout. In a state machine. Okay, so the grid layout is gonna be the dog. We're gonna say 5, so we have 25. Gonna add some random space here so they don't look like they're in a grid. For the state machine, I'm gonna use the state 1, so they're gonna be running. And again, like now it's gonna be just a simple example of the agents running straight, adapting to the terrain. You might, drive these agents with a curve, with other modules, by creating your own blueprint for driving their direction and things like that, using a navigation mesh and so on. Okay, cool. So now we want also terrain adaptation. So I'm gonna create a new collision channel. So here I'm gonna call it ground. I'm gonna keep it to blocks, so the landscape here will have it automatically. I'm gonna go in the height field here. Let me just select another one so we can refresh that. And now the dogs are actually adapting to the terrain. I'm gonna just move this agent group over here. And also for the player start, because yeah, I think it's under the ground. I'm just gonna move it on top here. Okay, so that's fine. I'm gonna just press play. So now we have our dogs running on the plane, on this landscape, and adapting to the terrain. Again, here the simulation is nothing fancy. I mean, the dogs are just running straight. Okay, so this is all for this video. I hope you found it useful, and thanks very much for watching. See you in the next video.